Hello friends, welcome to EC Academy. In this lecture, let us understand the system response by solving the differential and difference equations. Let us understand the procedure for solution to differential equation as well as difference equation. Now let us consider an LTI system with mth order constants, coefficient, differential equation as dm divided by dt y of t plus dm minus 1 divided by dt m minus 1 y of t plus and so on plus bm minus 1 d by dt y of t plus bm y of t is equal to x of t. Now if you find the solution to this equation, which is nothing but we are finding the response y of t. So if you find the solution for this expression, which is nothing but we are finding the response y of t of LTI system. So the response y of t consists of two parts. First one is homogeneous solution, which is represented as yh of t, and second one is particular solution, so which is given as yp of t. Therefore overall response of the system is given as y of t is equal to yh of t plus yp of t. This is the overall response of the system. Now let us understand homogeneous solution. Homogeneous solution is the response of the system when there is no input. So when there is no input, the response of the system is known as homogeneous solution. Therefore the differential equation can be represented as dm y of t divided by dtm plus b1 dm minus 1 divided by dt to the power of m minus 1 y of t plus and so on plus bm minus 1 dy of t by dt plus bm y of t will be equal to 0. In the above equation, if we put dm divided by dtm is equal to r to the power of m, then we can write the above equation as r to the power of m plus b1 r to the power of m minus 1 plus and so on plus bm minus 1 into r plus bm into y of t will be equal to 0. Once we find this equation, we can find the m roots of the above equation, which can be r1, r2 and so on up to rm. So these roots of the characteristics polynomial can be real and distinct, or it can be repeated roots, or it can be complex roots. Now let us take roots and its homogeneous solution. Now if the roots are distinct and real roots, then we will get the homogeneous solution as yh of t will be equal to c1 exponential to the power of r1t plus c2 exponential to the power of r2t plus and so on up to cm exponential to the power of rm t. We can write yh of t will be equal to c1 r1 to the power of n plus c2 r to the power of n plus and so on up to cm rm to the power of n. Now if the roots are repeated, at that case we can write the homogeneous solution as yh of t will be equal to c1 plus c2t plus c3t square plus and so on up to ck t to the power of k minus 1 into exponential to the power of rt plus ck plus 1 exponential to the power of rk plus 1t plus and so on up to cm exponential to the power of rmt. If the roots are complex, at that case we can write homogeneous solution as y h of t is equal to exponential to the power of alpha t into c1 cos beta t plus c2 sin beta t plus c3 exponential to the power of rst plus and so on up to cm exponential to the power of rmt. Now you need not get confused with this homogeneous solution. When we solve the problem, you will clearly understand this. Now let us understand particular solution. The particular solution arises due to the interaction of the system with input. So particular solution arises due to the interaction of the system with the input. So particular solution can be represented as yp of t, and this is the solution of mth order differential equation. Now let us take different input signal and its structure of particular solution. If input is k1, then yp of t will be k2. If input is t, yp of t will be k0 plus k1t. If input is Tp, then Yp of t will be K0 plus K1t plus and so on up to Kp Tp. If input is K1 exponential to the power of At, then Yp of t will be t to the power of m K2 exponential to the power of At. If input is t exponential to the power of At, in that case we can write this as k0 plus k1t exponential to the power of At as yp of t. If the input is k1 exponential to the power of At, then yp of t will be k2 exponential to the power of At. If the input is t into exponential to the power of At, then yp of t will be t to the power of m k0 plus k1t into exponential to the power of At. If input is k0 sin omega naught t and k0 cos omega naught t, then yp of t will be k1 cos omega naught t plus k2 sin omega naught t. So remember these particular solutions so that it is helpful for us to solve the problems. Generally, in signals and systems, there are two parts of solution of y of t. First one is natural response and second one is forced response. So natural response we can write it as yn of t, and forced response we can write it as yf of t. Therefore overall response of the system y of t will be equal to yn of t plus yf of t. Now let us understand natural response. Natural response can be given as yn of t, and yn of t is the system output with no input. So natural response is the system output with no input, hence it is also called as zero input response. So natural response can also be known as zero input response, which can be represented as yzi. So natural response can be given as yn of t is equal to yh of t with constants evaluated c1, c2 and so on up to cm using initial output condition. The natural response can be given as the homogeneous response with constant evaluated using initial output conditions. So this we will understand easily when we solve the problems. Now let us understand the force response. The force response can be represented as yf of t, and it is the response of the system due to input signal with 0 initial output conditions. So with 0 initial output conditions, the response of the system is known as forced response. Hence it is also known as zero state response. Hence it is also known as zero state response, that can be given as yzs of t. So we can obtain the force response yf of t from yh of t plus yp of t with constants c1, c2 and so on up to cm evaluated using initial output condition. There are two methods to find the solution. Method 1, let us consider y of t is equal to yh of t plus yp of t. First step is to find the homogeneous solution of the system yh of t with constants c1, c2 and so on up to cm. Second step is to find the particular solution yp of t and estimate constant k, and third step is to find total response y of t by using y of t is equal to yh of t plus yp of t. Then fourth step is to find constants c1, c2 and so on up to cm using initial output condition. So this is the first method. Now method 2, let us consider y of t is equal to yn of t plus yf of t. So this can be written as yzi of t plus yzs of t. In method 2, first step is to find the homogeneous solution with constants c1, c2 and so on up to cm. Second step is to find the particular solution and estimate constant k. Third step is to determine natural response using yn of t. Then fourth step is to determine forced response using yf of t. Finally, we need to determine the total response as y of t is equal to yn of t plus yf of t. This is about solution to differential and difference equation. Hope you have understood the topic. Thank you.